Oh, I'm not ready. No, you can go. We can go ahead. Yeah, I'm just kidding. Yeah.
All right. Good morning, everybody.
Welcome to ultrasonic leak detection. I know I was supposed to say something. Oh, well, we'll just move on. We'll move on.
Okay.
Jeremy Thorp is an instrumentation technician that has been working in oil and gas since 1999. With a background in maintenance and automation, his focus is now environmental field services with Intricate Group. Their focus in this field is fugitive emissions, leak detection, MSAPR, and compressor seal vent testing. Thank you, Jeremy, for doing this. I will. That's about the right height, hey? We're good to go?
Yeah, I think so. I've got this one too. Are they going to interfere?
No? They might actually.
Oh.
Do that.
Okay. Either way, I'm good.
Awesome. Thanks, Jeremy.
Thank you. Got to do some reading here today because I do not have this all locked in, but that's all, it's all good.
Just in case.
You bet. There's Jillian. Blair. So I've been asked many times how long I've been doing leak detection for, and like I'm only 44, but my smartass response is I want to say I've been doing it for 40 years. When I was 4 or 5, I got a brand new red BMX bike and my dad showed me how to check the tires for leaks. And in Dawson Creek, where I grew up, there was lots and lots of reasons for you to have slow leaks on your tires. So for about 10 years running, my dad would have been looking for his 9/16 wrench and it's probably laying on the lawn or wherever I left it. So he still kind of attributes me taking my bike apart, looking for leaks on my tires for the last, well, probably to this date. I'm not using his tools anymore. I got my own, but AVO, audio, visual, and olfactory are still the most commonplace leak detection methods in industry. Two of those would have been taken care of with me looking after my bike tires. If you can see it, hear it, or smell it, you probably got a leak. But now you've got to deal with it. Operations staff in the field every day are using their senses to keep themselves safe and to detect leaks. Leak detection has come a long ways in the last 20 years. Optical gas imaging cameras are amazing, and they made it able for us to survey an entire facility in a relatively short period of time. We can still pinpoint the source of a leak with soap, or contrary to manufacturer's specifications, use a personal monitor to sniff out a leak. It's what operations do. It's not necessarily the right thing to do. The old methods are still valid, whether it's AVO, taping flanges, and using a sniffer, soaping. These are all effective, but they all take a lot of time. Oops. So if you are using a sniffer and you find a leak on a flange, the procedure is always to isolate, blow down the pipe, reflange, a lot of redoing. You're changing gaskets, you're inspecting flanges, retaping threaded connections. It's all taking a lot of time. Or in liquid parts of process, whether it's produced water, oil, we're able to pinpoint those leaks pretty safely when facilities are in operation because you've got drips. Sorry guys. So in the mid-2000s, I worked for a larger oil and gas company, and we decided to start having fugitive emission surveys completed. It's well before there was regulatory requirement at the time, so the push was mostly safety and financial. Surveys were completed, and back then quantification was done based on visual estimates. We would receive those reports and find that they would come out with financial numbers associated with each leak. So whether it was $10 a year for this leak, $5 a year for this leak, $20,000 a year for this leak, operations staff really focused on the high-end ones, not necessarily on all the small leaks over an entire facility. Now, over a big company, all of those small leaks they would add up to a large value. But as far as a specific operation, a specific plant, nobody would really pay attention to them because a lot of the leaks were really small to begin with. Fugitive emissions was something really new back then. So often the report would come in after turnaround, we'd have a survey done. Operations would put that on a pin board. It might stick around for an entire year. So this is like previous to 2010. Pin to a pin board, wait around for next turnaround, and now you've got to remember to go and refer to that to fix all those leaks from the previous year. So quite often, things didn't get all fixed up. We'd have another survey done shortly after the turnaround. It was an ineffective system. So really, the only leaks that anybody would focus on would be if we had an LEL detector in a building, and we'd return to that one to try to repair it. So doing a fugitive emission survey after a turnaround is really just, you're looking in the rearview mirror. You're looking at work that you've done, and it's really a report card on the work that you've already done. So what we did as a company, we decided at that point we're going to buy an OGI camera. So we bought one of the expensive cameras so we could do our own OGI surveys over and over again throughout the year. So if we had an outage, we could do a survey. So we often had leaks on valve covers on compressors or fuel connections, and these buildings are difficult to survey with an OGI camera in because there's a lot of heat, temperature, a lot of moving air and that sort of thing. So it makes it really difficult. So even when down for a short time, operations, their main goal is to get that facility up and running again. They're not really focusing on all those small leaks that we might have had listed out on that pin board. So the OGI camera also is often locked up because of its expense, and with all the people around, they didn't necessarily know how to use it. So finding that some of these methods were ineffective, we got serious, and as the company's culture shifted, we decided to get our fugitive emissions in check. We had our own OGI camera. We started soaping connections as part of regular routines that operators were doing daily. And the guys had flag tape. And often the flag tape, like I have a major pet peeve about flag tape, being an instrument guy out in the field, means different things to different people, but often what it was is just somebody tied a flag tape on a leak, but that could mean that the valve was supposed to be closed, or that valve was supposed to remain open. Did it mean that really tall guy hit his head on that pipe? You don't get to know what the reason for that flag tape is, which is why now we go and we will actually flag and tag with specific details on leaks that we find. So identifying a leak takes time and effort. Following up on that leak and reporting takes time and effort, and both on the survey company and the duty holder. Reportable fugitive emissions life cycle does not end once it's repaired. These fugitive emissions are touched on often by several stakeholders throughout a company, from the point of find to the point of when it's actually repaired, and then afterwards, and reporting to the government afterwards. So since those days, there's now regulations that duty holders must, there's regulations that stipulate that we must do fugitive emission surveys and screening. So as an example, in Alberta, if you have a 601 subtype, a compressor station, you're required to survey these triannually. These surveys must be conducted using equipment that is capable of detecting hydrocarbons down to 500 ppm, or OGI cameras that can detect down to as low as 1 gram per hour. And that's the table right out of Directive 60. So getting to zero fugitive emissions is not impossible, but it's a lot of work. So for operations, addressing leaks and fugitive emissions before they would be fugitive emissions would be ideal. So there are methods and technology available to quickly take care of this. In the scenario of a turnaround or during construction startup, commissioning, during pressurization or purging, crews are on standby to address any leaks that may be occurring during the pressurizing with nitrogen or even air. So the problem with those, with nitrogen and air, is that they need to be detectable in order to address them. So there's not currently an OGI camera that's available to detect nitrogen due to the nature of the air that we breathe. If we brought a nitrogen finding camera into this room, it would just be saturated because there's a lot of nitrogen content in the air. So in order to detect a leak that has the same basic components as the air we breathe, there needs to be another method other than thermal optical gas imaging. Apologize for the air compressor. So ultrasonic leak detection, whether it's using a camera such as the one that's on the tripod over there, or the one on the photo in the slide, it's a microphone style. So you can pinpoint a leak source by aiming the microphone with your headphones on, and really a little display which has got a graph on it that tells you that you're finding a leak. So you're just walking around like this. But ultrasonic cameras like this guy over here have 112 microphones on the back of it and a camera on the back that are able to triangulate an image on the screen. And it's actually detecting a leak right now, but I'll get there in a second. So pressurizing a facility with nitrogen takes care of purging the system of air. And when performing repairs and at the right pressure, it's easy to find the leaks, and it's easy to do a repair where you don't have to worry about the inert gas repurging if you've already brought process fluids and gas into the system. So this is one that we've got here that would not be able to be detected with an OGI survey. So there's no hydrocarbons present. It's an acid gas compressor. So it would be about 97% CO2 and 3% H2S, if I remember correctly. So not detectable with a standard OGI camera, but with this camera here, the ultrasonic, we're able to pinpoint it exactly where it is. It's another example of a cooler, compressor cooler. Due to the wind and height, you wouldn't be able to soap any of these connections up here. And even with wind, height, and everything else in the way, depending on the wind direction, shooting it with an OGI camera, you might not ever pick this one up just due to the fact that it's that high up in the air. Quantifying certainly would not be possible. Again, with the ultrasonic camera, we're able to pick that up right away. This is a different one. This is an instrument air system. So it was in a large, noisy process building, and the leak was detected on an instrument air line just downstream of a pressure control valve on the instrument air system. So an air leak doesn't necessarily affect your methane reporting or have any regulatory implications at all. But what can and does happen is if there's enough of these small leaks in a facility, it ultimately does affect your production, because you're going to have an outage at some point, either just due to the labor on your instrument air system, or maybe you just finally get the leak that breaks the camel's back and your instrument air system isn't able to keep up. So actually looking at the bottom of this one, this area right here, the leak is here, but we're seeing a reflection. Ultrasonic acts it's reflected like a mirror. So once you get more experience when you're actually using one of these units, you can see that when you look at this leak, if you step back and forth a little bit, this guy's going to move, this guy's going to stay stationary. This is not another leak, but it's just something to keep in mind if you're using one of these units. So normally we wouldn't have this guy on a tripod, but it works better if I don't have to run around in this room too much. Yeah, so I don't know if everybody can see this here, but there is actually a leak being, I faked a leak in with a regulator and an air compressor for what you'd normally see all over your facilities. And you can see that barely a leak on there, like you can hear it right now. But it's barely there, and you can see it's picking it up really no matter where it is. This leak here, depending on where you're at in this noisy room, you might see it from all the way across the room, you might see it from about 100 yards away. And really what you're doing as you're working with this camera is you're playing with the threshold. So you're wandering around the facility with it, and you play with the threshold to see where you start getting a lot of noise. I don't know if everybody can see again, but I'm going to do some stuff. And it's not going to do what it does in a noisy process building, but there's times where you're using this unit and the whole screen gets saturated. So all you're doing is you're constantly wandering around. It's as easy as really just adjusting a knob to make sure that you're tuning out all the extra noise in the background. And of course you can take pictures of it, and you can take video and work with it that way, so you have something for your reporting afterwards. The company that sells this unit has software, so that you can do a quantification off of your leaks. It's not something you can use for AER regulatory fugitive emission surveys, but you can use it for finding leaks ahead of time and know what your leak may have been at just based on what the nitrogen is leaking out at. So you are able to determine some rates. So you do need to have some pressure behind your leak in order to find it. This one's only at 140 kPa, pretty low, relatively. Normally what we'll see is you'll have a company will pressurize up to whatever their operating pressures are before commissioning and going that way. So 5,500 kPa, 4,500 kPa, something in there is definitely going to start producing some leaks for you, or producing some results. So yeah, actually there are limitations. So ultrasonic leak detection does have limitations, and any gas leak can be detected, whether it's air, nitrogen, CO2, but it definitely has to be from a pressurized release. One of the places that you cannot use something like this for is a release, say, that you'd normally be shooting with a fugitive emission camera. Tank thief hatches, tank vents, that sort of thing. This guy isn't going to see that at all. It has to be something that, when I'm trying to explain it to people, I say it has to whistle. So there has to be some sort of a pressurized release point, something that can make the S sound, something that can whistle that way. And that's really the only limitation as far as that goes. What I really like about this technology is how easy it is to use and demonstrate. Obviously, slap together a tripod and a stand, and you can see what it can do right away. Operations and repair technicians, or whatever kind of technician fix this guy, you can see the results right away. I've probably no need to worry about that leak right there, because he's got stainless steel, so that's good. And then there's two wires, so it's double good, just like that. There's no worry about that flying apart, I'm sure. So yeah, benefits of ultrasonic leak detection. Really, you're reducing your carbon emissions by finding a leak before you have your process fluids in it. So you're reducing carbon emissions, you're reducing what you're paying in taxes and that sort of thing. You're enhancing your social license. You're able to instantly and reliably detect leaks and fix on the fly, or in the case of construction, safely address them before there's a startup, while crews are still on site waiting at the ready to come and do these repairs. And I'm kind of, yeah, that's just more of what I just said. So, see that I kept a slide in there that I didn't mean to. And I'm at the end of my presentation. But yeah, if anybody has any questions, I mean, you can come up and play with this thing. It's pretty straightforward. It's a really easy unit to use, and like other companies do make these. This one actually, the reason I like it, it's called a bat cam. It's my main point of picking this unit. But FLIR makes a unit now. So does Fluke. They make an ultrasonic camera. They're all around the same price point. It's really just picking what works best for you and your company, and taking care of some fugitive emissions on you before they're fugitive emissions. That one's about $20,000, and that's like, they've gone up, I'm guessing. We paid less than that at first. Far better than paying $140,000 for a FLIR. Not intrinsically safe, so the FLIR camera, you can be intrinsically safe, but technically you're working with this thing. Worst case, you need a hot work permit, but you're able to use this guy before you've got hydrocarbons in the lines. But yeah, like, they're available to rent, definitely purchase, but the ease of use is a big one. I find with some of the OGI cameras, there's a lot of interpretation when you're looking at some of these things. I don't know if everybody's seen the images and videos that come from those cameras. I compare them to when you're seeing an ultrasound photo of or like, everybody's probably been into an ultrasound, and they're doing the ultrasound to see the sex of the baby or looking at the toes, and the person's telling you there's 6 toes and there's 2 toes and there's this and there's that. Similar to the OGI. I don't know how those people do it. I can read what an OGI camera can punch out, but it's hard to look at sometimes. That's why we incorporate a lot of the visual optical images as well with them.
So you got a compressor panel
Yep.
that ran on this air, and we opened it up like most leaks. would the camera focus on one and just identify?
Everything that's there. If I had 6 of those regulators out in front right now, absolutely, you'd see every single one of them. Yeah. Where's the softball questions, Blair?
Well, yeah, share some stories, like what's some experiences you've had where the client didn't think there was a leak and then you found a leak?
Actually, those ones on the coolers. Most of the time, they're outside. Like I said, it's a hot surface to begin with, and around compressor coolers, there's a lot of wind. You're dealing with wind and everything. Wind because there's a giant fan pulling it all in. But the one cooler, they had said, like, there's a smell there all the time, but they just figured because the concentration was so great inside this compressor of, like, basically acid gas, that they figured that's what it was. But all down the one bank, every time we would go and fix one more leak, you could start seeing more of them. Like, they weren't masking one another, but what we were finding was the camera does focus. It'll bring up all of them, but I was fine-tuning and tuning out because I thought it was background noise. But realistically, the entire bank of cooler ends on that one bundle was leaking. So that works out really good. And when somebody goes up to put a wrench on it, like if it's relatively low pressure, they put a wrench on it, you can have it and shooting a video at the same time, and the leak just goes from this just to, right now it's gone. And that's on the CO2, but we're at that facility to do nitrogen tests. They were purging.
What's your range of these cameras?
The manufacturer specifications say about 6 meters, but I've had this exact same setup and been able to detect a leak across a quiet lease by about 100 meters at times. So shooting a tower, we've done that. Never produced any results. We still go up and we'll get closer to the flanges if possible, or using man lift. But for the most part, yeah, you're able to detect from a long distance away.
When you go to site, do you just start whipping the camera out and just do like a broad?
Willy-nilly style, man. Like, just get out there and do it. No, it's, yeah, specifically, like, wherever operations points us, we just kind of go where we're told, I guess. But typically when you're doing a nitrogen purge, they don't want to just pressurize an entire facility all at once. You're different sections and work that way. On commissioning, quite often they'll do a pressure test with air ahead of time. Like on a facility that's had no hydrocarbons in it ever, pressurized with air. That's brilliant because now you're not even worried about oxygen deficiencies or anything like that. Nitrogen, that is the one concern. Obviously, if you're inside of a building, you're up on scaffolding or ladders, your monitor is important at that point. It's always important, but it's when it starts chirping, everybody starts panicking a little bit. Yeah. So this unit can actually do corona detection. So if you have a substation and you're dealing with high voltage lines, so all your transformers, all of your insulators, if there's invisible arcs across, it'll pick them up too. I've never done that, but that's one of the selling points of these cameras as well. So you can stand outside of a substation and actually shoot for potential failures in the future. It's more on the big, like, power distribution systems.
Other than the intrinsically safe, is there any other environmental implications?
I've never used it in a Calgary-style hailstorm, but I would suspect that you would be, the screen would be saturated. So if you're watching a crowd of people walking, just even footprints, like you can see as they're walking. So if you can imagine rain, it's not going to do it because I'm not set up for it. But if it was a rainstorm, I think you'd probably be able to see the water droplets hitting. But that would be it. I mean, snow, we've used it in the cold lots. Certainly if it's it's noisy environments. So if you're in a compressor building and it's in full operation, so normally you can stand back and you can scan a whole room and then maybe focus in on a few pieces of equipment. But in a compressor building that's in operation, you've got to get closer to those units, like, or closer to your flanges, because you're tuning out a lot of the background noise by working with it. You're going to have to spend more time in an operational compressor building for sure. But $20,000 camera. I wouldn't use it in the middle of a monsoon necessarily, but
Does that tell me how much volume is coming out of the little regulator there?
oh yeah. So there's a cloud-based system for this particular unit. There's a cloud-based system where you can take a video right now, and it'll base off of your settings that you've chosen, so your range and your threshold, and it does do an auto measurement, which isn't necessarily on right now, probably because of the angle. But if you took your measurement down and punched that into the system, based on this intensity right here, it'll give you an estimated rate of leak. So, I mean, this one would probably be under 4 liters a minute, I would guess, but maybe less than a liter a minute. But the software will give you that.
So after coming from the site, you give a report to the client as to...
Yep, and you can use this. Different than the FLIR software that uses the same sort of information. This is not plume based. This is noise volume based. So it really can see sound. So it is an interpretation to some extent.
Are there certain places that you find leaks commonly?
Regulators. Yeah. No, the vent source on regulators, and I mean with the ultrasonic, we're really there to inspect process connections. With this guy, this is the one thing that if you're walking around with a group of engineers and they're all watching behind you as you're using the camera, everybody's wondering if the thing's working. So half the time you're just proving that it's working. So I'll find a regulator like this, crack it, and then stand way back, and then now you've got everybody's attention. They're watching you and saying like, well, let's go shoot some more stuff. And it's really the proof. And you're checking like that constantly, because I mean, I question it too, like, is this thing actually working? But it's just a good check constantly. And there isn't very many facilities out there that don't have a Fisher 67 regulator bolted somewhere. Like fixed like this? During CsHm presentations, I like to fix it to things. No, not very often. Like there is applications for that. It is like it's in the manual for the thing. Like they talk about setting it up to record because you might have maybe a line that's intermittent use and you want to catch it when it's doing it. So you can set it up to record. Like I can't remember what the length of time that you can record over. As far as being able to alarm or something off of that, I don't think so. You'd have to play it back to watch.
Is there benefit if you could have the FLIR and that together? Like how would those two tools
That's exactly what the reason that we ended up by getting something like this. Because what happens is you're at a facility doing fugitive emission surveys, and then somebody's like, I got an air leak on my on my instrument air header somewhere, but I can't find it. Or the CO2 system while we're at a facility. You can't do anything with the FLIR. I mean, it's a $140,000 camera that can't see, it can only see hydrocarbons or whatever type of gas that camera is tuned for. So this guy is strictly, it doesn't care what the medium is. If it's a vacuum leak or a pressurized leak, this guy's going to be able to pick that up. So that's where this comes in handy. It also helps when you're demonstrating, because like I said, when there's a lot of interpretation on the FLIR or any of the other optical gas imaging cameras, you can see something, but it's hard to describe what you're seeing and showing everybody what you're seeing, because I mean, I can see it, I know what it is, but you're trying to show, well, yeah, you can see he's got 6 toes on this foot, and it's hard to explain. But this guy, it's a blotch on the screen. It works perfect. Same. Yeah, same. Oh yeah, no plume, just it's a blob. Yeah.
If you don't have enough pressure to operate the camera, what would be your option to detect possible leak?
Now you're into soaping. So, I mean, this is relatively low, what I've got this set at right now. It's sitting at about 40 PSI, 100 and change kPa. Ideally, more pressure is better. It helps you see it better. And in this case, it's there, but you'll be able to detect a leak as long as there's something, if it's able to make something audible, it's there. Yeah, definitely more is better, more contrast, but if it happens to be a lower pressure that you're working at, that's fine. It seems to pick it up. Miles Thorp, do you have a question? No? Nothing? Hey, it's fine.
If there's nothing else, sure guys?
Come up and play with it if you want after. It's all good.
Thank you, Jeremy. That was really good. Thank you, Jeremy. Just don't forget to stick around to the end of the day. We're doing our draws. And also really make sure that you go into the app, pull up this paper, scroll down, find Jeremy's name, go in there, scroll down, hit the rate this presentation. It's a bit of a walkthrough. But please provide feedback. We do use that feedback, so we'd appreciate that immensely. But if you haven't got your little gift, there's go visit the ladies at the registration desk.
Okay.
And we sincerely appreciate it. Thank you for your help.
Thank you.